This video will look at linear sequences. Linear sequences increase or decrease by the same amount each time. They're also called arithmetical progressions. The difference between each pair of consecutive terms in the sequence is called the constant difference. Here we have a sequence. At the top here we have the pattern or the term number. Underneath we have a visual model of each term in the sequence, and then we have a numerical sequence underneath. So in the first term we have one red square and two yellow squares, which is a total of 3 squares. In the second term we have 5 squares, the third term we have 7 squares, and in the fourth term we have 9 squares. So how could we describe this sequence? Well, one description could be start on 3 and add 2. The next 3 terms in the sequence will be 11, 13, 15, and it will continue on going up in 2s. But what will the 327th term in the sequence be, or the 1000th term, or the 519th? There needs to be a rule for finding out any term, usually referred to as the nth term, in the sequence. So here's our sequence again, this time without our visual models. So we've got our first 7 terms, 3, 5, 7, 9, 11, 13, 15. And we're going to look at how the pattern grows first. So we can see we have a constant difference of add 2. So the difference between each pair of consecutive terms is 2. So every term is 2 more than the term before it, just like in a 2 times table. But the problem is the first term is 3, not 2. 1 times 2 is 2, not 3. 2 times 2 is 4, not 5. So as the first term is 3 and not 2, we need to find out what happens to 2 to become 3. Well, 2 plus 1 is 3. The adjustments that happen are always going to be addition and subtraction. So does it work for the further terms? Well, 4 add 1 is 5, 6 add 1 is 7, 8 add 1 is 9, and so on. So yes, it works. 2n. To find the 327th term, therefore, or the 327th number in the sequence, we're going to calculate 327 multiplied by 2 plus 1, which is 655. So the rule for any term, the nth term in the sequence, will be n multiplied by 2, add 1. If we write that using algebraic notation, we'll write 2n plus 1. So let's just recap the process. We start with the term number, we multiply by the constant difference, and then we add or subtract to get to the term. So here I have my term numbers, 1, 2, 3, 4, 5, 6. Here is the sequence, 2, 5, 8, 11, 14, 17, and the constant difference between each of these terms is 3. To make sure that I get the right rule, I'm going to check my calculations for 3 different terms. So on my table, I have down the left-hand column the sequence, each term in the sequence. I have the term numbers, which is multiplied by the constant difference, and then I have subtracted 1. So 2 equals 1 multiplied by 3, subtract 1. 5 is going to be 2 multiplied by 3, which is 6, subtract 1. 8, which is the third term, will be 3 multiplied by 3, subtract 1. So for n, for any term number, I will multiply it by 3 and subtract 1. So the sequence rule is 3n minus 1.